Hello and welcome to this GCSE Science revision video for core chemistry on the changing Earth. In this video we will look at the structure of the Earth, how plate tectonics have changed the Earth, the atmosphere and the carbon cycle. The Earth's crust, its atmosphere and oceans are a source of materials that humans have used for many thousands of years. The Earth is made up of distinct layers. The outer layer is the crust. The crust is about 0 to 60 kilometers thick. The crust is a solid rock layer that we live on. Underneath that is the mantle. The mantle is the widest section of the Earth. It has a thickness of approximately 2,900 kilometers. The mantle is made up of semi-molten rock called magma. In its upper parts, the mantle rock is hard, but in its lower parts it is soft and begins to melt. In the mantle, there are convection currents which move the continental plates around. Beneath that is the outer core. The outer core is a layer surrounding the inner core. It is a liquid layer, also made up of iron and nickel. It is extremely hot, with temperatures similar to the inner core. The movement of the outer core around the inner core is what generates the Earth's magnetic field. The inner core is the centre and is the hottest part of the Earth. It is solid and is made of iron and nickel, with temperatures up to 5,500 degrees. With its immense heat energy, the inner core is like the engine room of the Earth. The Earth's atmosphere surrounds the crust and is what we breathe. The Earth's early atmosphere is believed to have formed about 4.5 billion years ago. Its early atmosphere was probably formed by the gases given out by volcanoes. It is believed that there was intense volcanic activity for the first billion years of the Earth's existence. The early atmosphere was probably mostly carbon dioxide with little or no oxygen. There were similar proportions of water, ammonia and methane. As the Earth cooled down, most of the water vapour condensed to form the oceans. Photosynthesis by plants and algae used carbon dioxide from the atmosphere, but it is not the only reason that the proportion of carbon dioxide in the atmosphere decreased. These processes below outline other reasons. Carbon dioxide dissolved in the ocean. Carbon dioxide was used up in the production of sedimentary rocks such as limestone, and carbon dioxide has been used up by the production of fossil fuels from the remains of dead animals. The reason that the percentage of oxygen increased in the atmosphere was due to plant and photosynthesis. This process uses carbon dioxide from the atmosphere with water and sunlight to produce glucose. The appearance of plants and algae caused the production of oxygen, which is why the proportion of oxygen went up. The Miller-Urey experiment aimed to prove that the gases in the Earth's early atmosphere would have been able to produce amino acids which were required for life to begin. The aim was to see if substances now made by living things could be formed by the conditions thought to exist in the early Earth. Two scientists sealed a mixture of water, ammonia, methane and hydrogen in a sterile flask. The mixture was then heated to evaporate the water to produce water vapour. Electrical sparks passed through the mixture to simulate lightning. After a week, the contents were analysed and amino acids were found to have formed. The Earth's crust and upper part of the mantle are broken into large pieces called tectonic plates. These are constantly moving by a few centimetres each year. This process is called continental drift. The plates move because of convection currents in the Earth's mantle. These are driven by heat produced by the natural decay of radioactive elements in the Earth. Where tectonic plates meet, the Earth's crust becomes unstable as the plates push against each other or ride underneath each other. Earthquakes and volcanic eruptions happen at these boundaries, and the crust may crumple to form mountain ranges. The theory of plate tectonics was proposed at the beginning of the last century by a German scientist named Alfred Wenger. It took more than 50 years for Wenger's theory to be accepted. This was because it was difficult to work out the mechanism that could have made whole continents move. It was not until the 1960s that there was enough evidence to support this theory. Tectonic plates move because of convection currents in the Earth. Some of the main pieces of evidence for continental drift is that we have now been able to map the seabed using satellites from space. If you go and cut out the side of Africa, it fits into the side of America. There are similar fossils found across the world, suggesting that at one point all of the continents must have been joined together. And there are similar rocks with the same magnetic properties in different parts of the world that must have formed at the same time and in the same areas. The carbon cycle describes how carbon dioxide is taken from the atmosphere and trapped. The first way that carbon dioxide can be taken out of the atmosphere is by photosynthesis by plants. Carbon dioxide can also be taken out of the atmosphere by dissolving it in the sea. There are more ways that carbon dioxide can go and be put back into the atmosphere. The plants can go and be eaten by animals. These animals can die and decay, which releases carbon dioxide into the atmosphere by the respiration of microorganisms. They can go and turn into oil and natural gas, which when burnt releases carbon dioxide back into the atmosphere. The animals can produce shells which are made of limestone and chalk. This traps the carbon dioxide, however, when heated, the carbon dioxide is released back into the atmosphere. Plants and animals can respire, which releases carbon dioxide back into the atmosphere. And plants can turn into coal, which when burnt releases carbon dioxide back into the atmosphere. So remember, when revising, start earlier rather than later. Remember to turn off any distractions, and quality revision is better than quantity of revision. Please follow the link below for a summary sheet on this section, and good luck with your exams.